بسم الله الرحمن الرحيم وبه نستعين. This is review for chapter 5 and we are going to solve some questions together. So the first question, simplify, include the absolute value symbol if necessary. If the answer is not a real number, state so. In this problem, we need to find the cubic root of negative 9z to the power of 2 all to the power of 3. And we know that cubic root and power 3 are inverse operation. So the cubic root will cancel power 3. So the answer should be negative 9z to the power of 2. Select all the correct choices below and if necessary fill in the answer box to complete your choice. We have solved the problem already. So we can go for next question. Find all real fourth root of 256. So since the index is even, so we have to say positive or negative the fourth root of 256. Using calculator, we can find the fourth root of 256. So the answer should be positive or negative 4. Another question. Square root 9x to the power of 2. We know that square root of 9 is 3. And square root of x power 2 will be absolute value of x. We have said before that when we have a variable with even power under the root, like for example square root a to the power of 10, and it comes out like a to the power of 5, we have to put the absolute. When the power is even and the answer has an odd power, we have to put the absolute. If it's even, then even, no need to put the absolute, like x to the power of 8 will be x to the power of 4. So in this case, the original power is even and the result has even power, so no need to put the absolute. Another question. Cubic root negative 125x to the power of 12. Let's check the number first. Cubic root negative 125 is negative 5. So this will be negative 5 and x will have power 4. Why? Because we have said before the nth root of x to the power of m equals x to the power of m over n. So when we have the third root of x to the power of 12 means x to the power of 12 over 3, and 12 over 3 is 4, means x to the power of 4. Moving on. Find the two real solution of the following equation. X to the power of 2 equals 144. So we need to find out the x, means we need to get rid of power 2. So we put positive or negative square root of 144. And this will be positive or negative 12. Another question. The volume of a soap bubble is 659.2 millimeter cube. Find the radius and diameter of the soap bubble. Use 3.144 pound. So the soap bubble shaped like a sphere, and we know that volume of the sphere equals 4 over 3 pi r to the power of 3. So we know the volume now, so it will be easy for us to know the r, which is the radius. So let's substitute now. What do we know about the volume? The volume is 659.2 instead of v. Then we write 4 over 3 pi, which is 3.14 multiplied by r cubed. So now we are going to divide both sides by 4 over 3 multiplied by 3.14, so that r cubed will be 659.2 divided by 4 over 3 multiplied by 3.14. So the r will be the cubic root. Of course, in cubic root, we do not put positive or negative. Positive or negative is for the square root, and for the fourth root, also we have positive or negative. But cubic root, we don't have. So we put the number as is. Or you evaluate first, then you find cubic root. Whatever, it's up to you. I'm gonna put it as is so that I use the calculator only one time. And let's see R. Using calculator, the cubic root, 659.2, 4 over 3, 3.14, and this should be the radius. They say round to the nearest tenth, so this will be 5.4. 39 means 4. 5.4. Now the diameter equals 2 radii, means 2 times the radius, 2 times 5.4. This will be 10.8 millimeter. Moving on. Use the rules to find x to the power of half times x to the power of 1 over 7. Actually, this is a very easy question because we just apply the rule directly. X to the power of a times x to the power of b. This will be x to the power of a plus b. Means when we multiply same bases, we add the powers. So this will be x to the power of half plus 1 over 7. And you plus using calculator or using your mental math, this should give you x to the power of 9 over 14. Moving on. Cubic root negative 54, x to the power of 6, y to the power of 5. Let's check using calculator first if we can find cubic root of negative 54. Cubic root negative 54. Unfortunately, we cannot find it directly, so we have to write it down as product of two numbers. One of them we can find the cubic root of. So we know that 54 54, it is 6 times 9, and the 6 is 2 by 3, and the 9 is 3 by 3. So 54, it's like 2 multiplied by 3 multiplied by 3 multiplied by 3. Means 2 times 27. So this is the first step. This is a cubic root of 2 times negative 27. I keep the negative with the 27 because actually we can take a cubic root of any cube negative number like 3 to the power of 3. Now x power 6 is ready because power 6 is divisible by 3. So I'm going to leave it x to the power of 6. Y to the power of 5 needs to be ready because it's not ready right now as 5 is not divisible by 3. So I'm going to write it as y to the power of 3 times y to the power of 2. Now, let's highlight what we can take cubic root of. I can take cubic root of negative 27. I can take cubic root of x to the power of 6. I can take cubic root of y to the power of 3. So this is going to be 27 will be negative 3, x power 6, x to the power of 2, y power 3 will be y, and 2y squared remains under the cubic root. Moving on to another question. Simplify the following expression: square root x to the power of 5, y to the power of 5 dot means multiply 4 square root 3 x to the power of 9, y to the power of 4. Let's finish multiplication first as both of them are square roots. Here is unwritten 1, so 1 by 4 stays 4. Square root, and then we multiply what is under the square root. So this is 3. X power 5 times x power 9 will give you x to the power of 14. Y power 5, y power 4, this will give you y to the power of 9. Now, x power 14 is ready because we can divide 14 by 2. We can take half the power, but y power 9, it's not ready. So we can rewrite it as x to the power of 14, y to the power of 8 times y. Now, let's highlight what is ready to be outside. We can take the square root of x power 14. We can also take the square root of y to the power of 8 to be written outside. So 4 remains the same. X power 14 will be x to the power of 7. Y power 8 will be y to the power of 4. And the 3 and the y will remain under the square root. Square root 3y. Moving on. Cubic root 13n over 81 m to the power of 12. use the quotient rule to simplify. Assume that all variables represent positive real numbers. So we have to think of what is under the cubic root. Can we simplify what is under the cubic root first? In this problem, no, because 13 and 81, they don't share common factor except for 1. And n up, n down, so we cannot simplify what is under the cubic root. But we can think of how can we make the denominator to be a cube. A cube means something we can take cubic root of. Can we take cubic root of m to the power of 12? Sure, because 12 can be divisible by 3. Can we take cubic root of 81? Let's see. Cubic root of 81. Unfortunately, we cannot. Because actually 81, we all know that it's 9 times 9. And this 9, it's 3 by 3. And this 9 also, it is 3 by 3. So the problem is now that we have extra 3. Because 3 by 3 by 3 is 27. This is 27, which is 3 to the power of 3. And we can find the cubic root of, but we have here extra 3. So this extra 3, it needs to be multiplied by another 3 by 3 so that we can take the cubic root. Means we have to multiply by 9, down and up. So this is the first step. I'm going to enlarge the cubic root. And I'm going to write here 13n over 81, m to the power of 2, m to the power of 12. And I'm going to multiply by 9 up and 9 down. So this will be the cubic root of 13 times 9. It gives you 117. 117n, of course. 9 times 81. This will be 729. M power 12. Now, it's ready so that we can put cubic root up in the numerator, 117n, and cubic root down in the denominator, 729, m to the power of 12. And we are sure that we can evaluate the cubic root of the denominator. So this will be up stays the same, cubic root of 117n, down cubic root of 729. This should give you 9. So this is 9. Cubic root m to the power of 12, it will be m to the power of 4. So another question, add or subtract as indicated. 5 cubic root of 7 plus 4 square root of 7 minus 6 square root of 7. This is a very easy question because we have to gather like radicals together. Those we call them like radicals because this is a number root 7 and another number root 7. So we will keep 5 cubic root 7 the same. And 4 root 7 minus 6 root 7, it's like 4 minus 6. So this will be negative 2 root 7. And that's it. We cannot do anything else. Moving on. 9 square root of x minus 3 multiplied by 4 square root of x minus 5. So let's remember the rules of multiplication. We have the first case when we need to multiply a plus b times totally different parentheses like c plus d, for example, or minus, whatever. So for this one, we follow the FOIL method. We call it FOIL because we need to multiply the first by the first for the f, and O for the outer means a times d, and I for the inner means b times c, then R for the last, which is b times d. This is the first type of multiplication. Second type, it's a special product called sum multiplied by difference. Sum multiplied by difference when we have a minus b multiplied by an identical bracket except for the sign, which is a plus b. And we used to call it the conjugate, as it has special product. We just multiply the first by the first and the second by the second. That's it. Means it should give a squared minus b squared with no middle term. The third type of multiplication, when we have the exact identical bracket even with the sign. Yani we have like a minus b times the same a minus b. When we used to write it as a minus b squared, a minus b to the power of 2. So in this case, we make power 2 for the first, a power 2. And we take a space and we make power 2 for the second, positive b squared. And this space is for what? To multiply the first by the second times 2. So we say negative 2ab. What about if it was positive? So if it was a plus b times a plus b, so here will be plus, and here will be plus, means positive. So the sign of the middle term depends on the sign mentioned between brackets. And the last one is always positive. So in this case, this product, it follows the FOIL method, which is the normal multiplication method. Sometimes we call it FOIL, sometimes we call it distributive. Distributive method. Let's follow the distributive method and find out what is the final answer. So multiply 9 times 4, 36. Root x times root x is x. Multiply 9 times 5, 45. So negative 45 root x. Multiply negative 12 root x. Multiply positive 15. Now we have to take like terms together, like those are like. So we can say that this is 36x minus 45 minus 12. So it's like 57 root x plus 15. That's it for the final answer of this problem. Moving on. The parent function f of x equals root x and a transformation of the parent function g of x are reflections of each other over the x-axis. Reflection over the x-axis. So to show that this is reflection on the x-axis, we have mentioned before that if y equals f of x, and the new function g of x, it is negative f of x, this will be the reflection on the x-axis. So actually what we are going to do is we put here negative in front of the radical, means g of x should be negative square root of x. And to remind you with the graph, the normal graph of the parent function f of x is this way. This is the radical f of x. But now we have a new function that is the same as f of x, but reflected on the x-axis. So it goes this way, which is the g of x. Moving on. The graph of the function f of x equals root x minus 6. Is it A, B, C, or D? Of course, we can enlarge A to check. And we can enlarge C as well. So root x minus 6, and it's root x, then minus 6, means it goes down 6 units. And down 6 units, it is really C. Rewrite the function to make it easy to graph, means we are not asking you to graph, we just asking you to rewrite so that it's easy to graph. Rewrite as it's easy to graph. Means you take a common factor, because you know that 18, it's like 2 times 9. So we are gonna rewrite the problem as square root. I'm gonna take the 9 as a common factor. So it is x minus 2 now, then minus 1 still outside. Now I can take the square root of the 9 to be 3. So it will be written outside the square root as 3 square root of x minus 2 minus 1. Now everything is clear. Every transformation is clear. Describe the transformation. We can say that it has horizontal shift 2 units to the right, as minus 2 will make it to the right. And it has vertical shift 1 unit down, and it has vertical stretch with factor equals 3. Another question, rewrite the function to make it easy to graph using transformation. So actually we don't need you to graph, we just need you to rewrite and describe. Describe the graph means describe the transformations you wrote. So I'm gonna divide the 64 by 16 so that I can take the 16 as a common factor. 64 divided by 16, it gives 4. So I can take 16 as a common factor. So the function y will be equivalent to the square root, I'm going to take 16 as a common factor. So it remains here x minus 4, because 64 divided by 16 will give you 4. Now I can take the square root of the 16. So it's 4 outside now. 4 square root of x minus 4. Now, this is very clear. We can write down transformations now, as we have a horizontal shift. This one represents 4 units to the right, as it's negative. If it's a positive, we would say to the left. We don't have here vertical shift, so we can say no vertical shift. Or we can skip, we can just not mention. And we have here the whole graph, the root, the function multiplied by 4. So we can say that this is vertical stretch with factor equals 4. So take a common factor, take the root, then describe. Moving on. Write the function shown in the graph to the right. So we give you a graph, and we need you to write down the function. First of all, this one, it follows the parent function root x, because we know that if y equals root x, it gives the same exact shape, but starting from 0 and 0. We all know this. And we said before, if it has two branches, like one is going to the right and one is going to the left, this one follows cubic root of x. But this one, it has only one branch, so it is the square root of x. Now, check this point and check what is happening for the start. This is the start. It should be exactly at 0 and 0. What has happened? It moves to the left 6 units. Well, 5, let's count. 1, 2, 3, 4, 5. 5 units to the left. And how many units down? 1, 2, 3, 4. So it went 5 units left. Then it went 4 units down. But what if we have vertical stretch or vertical compression? So first of all, we need to write down the function y in the general form. In the general form, it's a number, multiplied by the square root of x minus h plus k. We know now the h and the k, so it's left to know the a. 5 units to the left means we put plus 5. So y equals a square root x plus 5. Plus 5, of course, to show that it's 5 units to the left. 4 units down means minus 4. Now, what about this a? To know this a, we need to take an exact point. Exact point. Of course, except the point that has moved. Yani, except don't take this one. Don't take this point, which is -5 and -4. No. Take another exact point, a point that you really sure of, like this one, for example. See this point? It is -4 and -2. Here is -4, and here is -2. We can substitute -4 in the place of x and -2 in the place of y. So I'm gonna put here -2 equals a, and we need to know what is this a. square root x, which is -2 plus 5 minus 4. I'm gonna move -4 to the other side. I'm gonna add those. So here will be +4, means -2 plus 4 is equal to a. I think I have to put here in the place of x -4, not -2, -4, which is this number on the x-axis. So I move -4 to the other side, -2 plus 4, a multiplied by -4 plus 5, which is 1. -2 plus 4 is 2. A times √1 stays a, so a is 2. This number is 2. So we can write down the final answer as y equals a, which is 2, multiplied by the square root x plus 5, then minus 4. So first of all, you check the horizontal and vertical shift. Then you set here a number because we don't know what is the a number. Then we pick any point to be substituted in the place of x and y to evaluate what is the value of the a. So we know now that it has a vertical stretch with factor equals to. Moving on. Solving equations, one of the important topics in the chapter. To solve the equation means to find the value of x. So cubic root 12x is equal to -4. We said before, the first step is to get the radical alone. After getting the radical alone, we do inverse operation. Means if it's square root, we should make power 2 for both sides. If it's a cubic root, we should make power 3 for both sides, and so on. So in this problem, since the radical is already alone and it's cubic root, so we make power 3. So it's like cubic root 12x all to the power of 3, -4 all to the power of 3 as well. Now, power 3 will cancel the cubic root, so that we can say 12x is equal to -4 power 3 is -64. And we should divide by 12 for both sides. Divide by 12 here and divide by 12 there. So x will be equal to -64 divided by 12. This will give you -16 over 3. And that's it for the value of x. Moving on. Solve the formula for c. Means imagine that c is like x. C is like x, and you need to find this x alone. So f equals p multiplied by square root 3 plus c. We said this c, this is what we need to know. It's like the x. So get the radical alone means we divide both sides by p. So it's like f over p now is equal to square root 3 plus c. Let's try to get rid of the square root by doing power 2 for the right-hand side, power 2 for the left-hand side. Power 2 will cancel the root. So it gives 3 plus c on the right-hand side, and it gives here f squared over p squared. Now let's take the 3 to the other side. So f power 2 over p power 2 minus 3 will be c. Now you can start with the c. C equals f squared over p squared minus 3. So just like solving a normal equation, but instead of solving for x, we are solving for c. Moving on. أيوة عبد الله. In this problem, also solving radical equation, and we need to make sure that the radical is alone. The radical is already alone. So we go for the second step directly, which is power 2 to get rid of the radical. 3x minus 2 power 2 equals 5 power 2. Power 2 will cancel the root, so it is 3x minus 2 equals 5 power 2, 25. Take negative 2 to the other side, so 3x equals 27. Divide by 3 for both sides, so x equals 9. Now go back and check whether 9 really works. We can use calculator to check. So the square root of 3 multiplied by 9 minus 2, is it really 5? It is 5, so our answer is correct. You can leave it this way, or you can write solution set equals 9. Moving on. Also, in this radical, you need to make sure that the radical is alone. The radical is already alone, so we go directly for power 2 for both sides. So the square root 30 minus 6x all to the power of 2 equals x minus 5 all to the power of 2. Power 2 will cancel the root. 30 minus 6x remains on the left-hand side. And here this will give x power 2 minus 10x plus 25. Remember to write down the middle term, as this is a mistake of most of the students. They ignore the middle term and the whole problem will be wrong. Now, this is quadratic equation, so it must be equal to 0. So x to the power of 2 minus 10x plus 25 plus 6x minus 30 is equal to 0. Now x power 2 minus 10x plus 6x is negative 4x. Positive 25 minus 30 is negative 5. Using mod 5.3 or using your skills of factoring, this will be x by x, 5 times 1, negative positive. So x should be equal to 5, or x is equal to negative 1. Now, we need to check whether both solutions are okay or not. So let's check for x is equal to 5 in the original equation. So I'm going to say square root of 30 minus 6 times 5, 30. I'm going to put here question mark. Is it equal to 5 minus 5? Actually, this one, it works, as here it will be 0 is equal to 0. Now, let's check x equals negative 1, whether it works or not. In the left-hand side, it's 30 minus 6 times negative 1, which is square root of 36, which is 6. Now, is it equal to negative x minus 5, which is x minus 5, which is negative 1 minus 5, means negative 6. So this is not equal because the left-hand side is 6 and the right-hand side is negative 6. So we say that negative 1 is refused, or you say rejected. or you say it's extraneous solution. Means the only solution is x equal to 5. So in the solution set, you just write 5. Moving on. Bracket with rational power. This is rational power, means a power in the form of fraction. And we know that powers in the form of fraction, like radicals. So I have to get it alone. So I'm going to move -4 to the other side. And I'm going to keep here x to the power of 2 minus x minus 4 minus 40 all to the power of 3 over 4. Of course, some smart students, they will say, okay, this is like a fourth root of power 3. It's good, but it makes the problem longer solution. So I'm going to leave it the same as 3 over 4. And I'm going to write here 4 plus 4, which is 8. Now, I'm going to get rid of this power, which is the power in the form of a fraction, by doing the reciprocal. 3 over 4, I'm going to put 4 over 3 for the left-hand side, and also power 4 over 3 for the right-hand side. Because actually, when we multiply these two powers, 3 over 4, 3 will cancel the 3, and the 4 will cancel the 4, means it's power 1 now, and power 1 is unwritten. So it's like x power 2 minus x minus 40. And this one you can use calculator to find out, or you can use your mental math. 8, it's like 2 to the power of 3, all to the power of 4 over 3. So it's like 2 to the power of 4, which is 16. Now I'm going to take this 16 inside. So x power 2 minus x minus 56 is equal to 0. Open parentheses, or use mod 5 1, mod 5 3. X times x, 7 times 8. The 8 is negative, the 7 is positive. The positive will give you a negative solution, negative 7. And the negative will give you positive solution, which is positive 8. Now, let's see if both are correct. Means I'm gonna check the left-hand side with -4 with everything, and we will see if this is really equal to 4. If it's really equal to 4, means the solution is correct. If it's not 4, the solution is incorrect. So let's see. I have here parentheses. I'm gonna put alpha x to the power of 2, then minus, I'm gonna use the alpha button to write the x, minus 40, close, power as a fraction, 3 over 4, and remember to write minus 4. Now I'm gonna calculate when x is 8. It gives the answer 4, so this one is correct. Let's calculate when x is -7. Let's see the final answer. It is 4, so both answers work. So we can say that solution set is equal to -7, 8. Moving on. The problem with two roots, we don't keep the two radicals. We don't keep the two radicals in one side. We have to split them. So I'm gonna move this one to the other side. So the square root of x plus 33 is equal to 7 minus the square root of x minus 2. Now I'm gonna make power 2 for both sides. Here power 2 will cancel the root. And here we are going to apply the rule a minus b to the power of 2, which is a squared minus 2ab plus b squared. So on the left-hand side, it is just x plus 33 On the right-hand side, 7 power 2 will be 49. Negative 2 times a times b, so 2 by 7, 14, times the root. It will be 14 square root x minus 2. Now, b power 2, which is the root power 2, so it will be positive x minus 2, as power 2 will cancel the root. Now, the root, as we can see, it is negative, so I'm going to move it to the left-hand side. I'm going to take the x and the 33 to the right-hand side. So it will be 14 square root x minus 2 is equal to 49 plus x minus 2 minus x minus 33. Now, positive x will cancel negative x, and 14 square root x minus 2 remains on the left-hand side. Now, 49 minus 35, because 33 and 2 both are negative. So this will give you actually 14. And if we divide by 14 for both sides, so the square root x minus 2 is equal to 1. Now we're gonna make power 2 again. So power 2 will cancel the root. So x minus 2 is equal to 1. Move negative 2 to the other side. So x is equal to 3. Go back and check whether square root 3 plus 33 plus square root 3 minus 1, is it really 7? Using calculator or using your mental math, this will be square root of 36 means 6. Square root of, it's minus 2, not minus 1. So square root of 1 is 1. And this is really 7, means your answer is correct. So x equals 3 is correct. Moving on. Let f equals negative 4 and 1, 0 and 4, 3 and 0, and g equals negative 2 and 3, 1 and 3, 2 and negative 2, and 4 and 0. Find f composition g. If we go back to what we have learned about f composition of g as a function of x, it is according to the definition, f of g of x means g of x should work first. So now, if we take the first order pair, the negative 2 gives 3 as an answer. So you check this 3 as an x value in the function f. See, the 3 here gives what? Gives 0. So this will be the first order pair, that negative 2 gives 0. Now, let's check another one. Also, we start with the g, as g is inside here. So for the function g, the 1 as an x gives 3 as a y value. Now we go check this 3 as an x value in the function f. See, it is also 3 and 0. So we can say that the number 1 also gives 0. Let's check another value. Start with the g as well. Here, the 2 gives a negative 2. So go check this negative 2 in the function f. It does not exist as an x value. Does not exist as an x value, so we do not take this order pair. Let's check the 4. The 4 here, it gives 0. Check the 0 as an x value in the function f. It's here. The 0 gives 4. So really 4, if we start with 4, it will give us 4 at the end. So these are the order pairs of the function f composition of g. Moving on. Moving on. Let f of x equals x power 2 plus x minus 2 and g of x equals x minus 1. Perform the function operation and mention the domain. The operation here is plus. يعني f plus g of x is equal to plus يبقى x power 2 plus x minus 2, then we put the plus sign and x minus 1. We gather like terms together. So x power 2 plus x plus 2x. And minus 2 minus 1 will give you minus 3. And since this is a polynomial and the domain is all real numbers, and this one is a polynomial with domain all real numbers, so for sure the domain equals all real numbers. All real numbers, or we can say from negative infinity to positive infinity. Very easy question. So let f of x equal to x to the power of 2 plus 15x plus 27 and g of x x plus 3, and we need f over g. So according to the rule, f over g as a function of x is equal to f of x over g of x. So f of x up, which is 2x squared plus 15x plus 27 all over x plus 3. So if we have any type of factoring, we should do it. How can we discover? Very easy. You can use your calculator, mod 53, and you put the numbers 2, 15, 27, and check for the numbers appear. Negative 3 means you have x plus 3. So we have one of the brackets like x plus 3. We always switch the number appears on the x when we are factoring. And the other one, it's negative 9 over 2. So we don't write it in fraction form. We write this 2 multiplied by the x. So we write it like 2x. And we change the sign and we write positive 9. So the factoring, as it's clear, it is x plus 3 to x plus 9. Down there, it is x plus 3 already. So we can simplify by canceling x plus 3 up with x plus 3 down. And the remaining expression, it is 2x plus 9. Now, when we talk about the domain is all real numbers except zeros of the denominator, because we have denominator here. So if you think of a zero of the denominator, it should be negative 3. Or if you cannot predict, just take x plus 3 and you say this shouldn't be equal to 0. Move 3 to the other side. So x shouldn't be equal to negative 3. So how can we show this? We say all real numbers except, and we put negative 3 between braces. This will be the domain. Or we can show it as interval from negative infinity to negative 3, union from negative 3 to infinity. So very simple. Put f up, put g down, do factoring, do simplify. After that, the domain will be all real numbers except zeros of denominator. Moving on. Let f of x equal negative 5x minus 1 and g of x equal x power 2 minus 2. Find f composition g of negative 3. According to the definition, this will be f of g of negative 3. So we evaluate g of -3 first. According to the function g, it should be -3 to the power of 2 minus 2. This will be 9 minus 2, which is 7. Now we evaluate f of 7. It is -5x, means -5 times 7 minus 1. So -35 minus 1 means -36. Another question. F of x equals 5x minus 9. G of x equals x plus 7. Find f of g of x. Means the function g is completely inside the function f. Means we need to find f of x plus 7. Means we sit here in the place of x plus 7. So 5 times x plus 7 minus 9. This will be 5x plus 35 minus 9. So this is going to be 5x plus 26. Now g of f of x will be g of f of x, which is 5x minus 9. So we set 5x minus 9, all of it in the place of x here. So it will be 5x minus 9 plus 7. So this is like 5x minus 2. How easy math is, how easy that chapter is. That's it, guys, for our review for today. And I wish everyone full mark in the exam, inshallah.